lesson is very closely related to the last lesson we did. It's about histograms. It's just a little bit more into it, so it's not too long for us to go through. So a histogram kind of looks like a bar graph. They're technically not just the same, but often people do confuse them. All of the bars have to touch in a histogram, and the numbers across the x-axis are continuous. You can't have a histogram that's about females versus males or something. They're all going to be touching just right there. And there's numbers at the bottom. And then on the left, it has to be frequencies on our vertical axis. And the height of the bar can correspond to the frequency. So in general, that's a histogram. Now, we use histograms so that we can very quickly look at the shape of the distribution of the data, and that's kind of what we did at the end last time. But also then we can tell where the center is because we can just go to the middle of that scale at the bottom. We can also see how wide it's spread out, and if there's any bars way out at the edges that are tiny short bars or just have a height of 1, then we know we probably have some outliers. Histograms then are visual representations of a frequency distribution. When we have a frequency distribution, which we dealt with last time, we had these numbers. We took some of those numbers, and we saw them in that StatCrunch histogram, but then our labels are going to probably have class boundaries. So you can see, kind of just depends on how they get made or what technology is used to make them. But if you see over here, this says 74.5, and yet over in this area, in our frequency distribution, the 74.5 wasn't there, the number was 75. So 124 goes in the first bin, but 125 goes in the second bin, so it's like that line gets drawn right in between them, and this line in between the first and second bar then on the histogram is at 124.5. A relative frequency histogram is pretty much the same, except for that instead of coming from a frequency distribution, it comes from that relative frequency distribution. So again, we talked about that before. So this is that same information where we have that relative frequency distribution, and then we've put that in a relative frequency histogram. Now again, if you notice the shape of the bars here, the heights of them, they are proportionately exactly the same in this other one, even though that color ended up being a little bit different. The numbers across the bottom are the same. It's just that we now have percentages on the left instead of frequencies. So when we look at histograms, there's several things we can do, but the red one here is what we are really focused on in this lesson. We will have other chapters where we do some things talking more about the center of the data. What is the variation? There's a lot more to come about variation. We have definitions for outliers and different things here. So what we're really looking at in this one is the shape of the distribution. Just like it was true on the frequency distribution, histograms are not very helpful if your data set is too small. In fact, they can become quite deceptive. You know, if there is one, if you have a class with only 10 people in it, and then one person does something, then that's 10% of the class. That's kind of deceptive because it would make some people think that it was 10% of a much larger population, but 10% can be 10% of a really small population also. So anyway, this one is about what's the shape of the distribution. That's this lesson. And really it's all summarized on this next one. I didn't go into a lot of details and examples here. We talked some in the last lesson about what the normal distribution is. And so even on a histogram, if it's not exactly that curve, but it does look pretty symmetric, starts low, ends low, it's symmetric around the middle, the highest values are in the middle, then we have a bell shape, which we refer to as a normal distribution. Anything that kind of levels off at the same height is uniform. If it were a perfect rectangle, it would be perfectly uniform, but this one's close. Now these two on the bottom are a lot more closely related to normal than that uniform distribution, but they're not, because they're not symmetric really. You can certainly tell that one half is not really like the other half. And what happens on that one is the one that's seen, this we call it the tail, really. The tail that seems the longest is the direction it is skewed. And we'll talk more about even what that can mean in another lesson. But we have skewed to the left or skewed to the right. As you can see on this next slide right here, skewed to the left or skewed to the right, the tail tells you. And those words sound almost identical with my accent. But you just want to look and just visualize where would the tail of this animal be. And if I could draw really well for you, I would draw you some sort of a dinosaur with a long tail growing across there. But I can't, so there you go, I won't. So again, we have normal, and then some that are almost normal, but they're a little off. You want to focus in on where the long section is. Is it skewed to the left or skewed to the right? The tail is how you determine that. Okay? We have one other concept in this lesson, and then that will finish us up. And that has to do with assessing normality with normal quantile plots. Now, first, good news, you're not going to need to make a normal quantile plot in this homework, okay? What you need to be able to do is look at one and determine if it shows normality. And the way you do that is not very difficult. Once you are looking at a normal quantile plot, what you're really trying to do is see if the points are all fairly close to a straight line and there's no other pattern that you can see. So you have to look real closely. Like on this very first one, they're all fairly close to this straight line. And there doesn't seem to be, if I connected the dots here, there would not be another pattern, although I can see where this kind of gets more difficult to tell that there's not a pattern. It's not exactly the same amount above and below. It's not balanced, where by contrast, if you'll jump over and look at this one on the right with me, these are all also close to this, but it is perfectly balanced that there are some above and some below, and it's close to it, but it shows a pattern that's not a straight line. So this one's not, because of this pattern that's not the straight line. It needs to meet both cases. Now, I don't think you're going to get confused about the ones that don't have any kind of a pattern and are not close. This one in the middle is pretty clear that that's not hitting close to the straight line. So if you see them close to the straight line, you have to kind of, almost squint your eyes and think, could these dots blur together and make some other sort of a pattern? And, if it's got a really strong balance, then you're going to want to choose that it's not normal, because it could fit like a curve there, like a little stretched out, I don't know, maybe a stretched out S or something, a wave. That would have been the better word. Stretch a wave, where this one's not a wave. So a normal distribution, close to a straight line, and does not show a systematic pattern that's not a straight line. Now, I'm keeping this video really short. We don't have examples from homework in it, but you guys can email me with an Ask My Instructor question, and I'm happy to help you on your specific problems, okay? And we'll just go ahead and stop this video, and you can get to work. Thanks.